In this video, we shall be finding the estimates of mean and beta for the Laplace distribution using maximum likelihood estimation. For more on this topic, you need to subscribe to this channel. The first thing to do is that we note that mu here is the location parameter. Also, beta is the scale parameter. We should also know that the sine function of x is equal to 0, 1, 0, minus 1. So we have x to be greater than 0, x to be equal to 0, and x to be less than 0. So this is the things we should note before we compute the maximum likelihood estimation for the Laplace distribution. So the first thing to do, if you want to compute the maximum likelihood estimation for the Laplace distribution, is to take the likelihood function. And the likelihood function of the Laplace distribution is equal to the product sum as I running from 1 to n of the given distribution. Mu all over beta. So this is what we get if we want to take the likelihood function. It then means that we can expand this because this sign means the product sum of the whole of that distribution. So we have it to be equal to, the likelihood function will be equal to 1 all over 2b, the first one, exponential, negative x1 minus mu all over beta multiplied by 1 all over 2b, the second, exponential, negative xi minus mu, the second one, all over beta multiplied by, it continues like that, you now get 1 all over 2 beta raised to the power of n exponential negative xi minus mu all over beta. This is what we get. It then means that our likelihood function of the Laplace distribution will be equal to, since it's the product sum, we'll now write it as 1 all over 2 beta raised to the power of n exponential negative, this is summation because we are summing n times of the values of xi minus mu all over beta. So this is what we get. This is what we get. The next thing is to take the log of the likelihood function. But we are not taking the log. We first rearrange this so that it will be very easy for you to take the log. So the next thing to do is to still rewrite this properly, which is the likelihood function of x to be equal to, this can be written as 2 beta raised to the power of minus n exponential summation of I running from 1 to n xi minus mu all over beta, which can also be written as 2 raised to the power of n minus n multiplied by beta raised to the power of minus n exponential negative summation of xi minus mu all over beta. So this is what we get as our likelihood function. The next thing to do is to take the log. Take the log. We'll take the log of the whole of this. So we'll move over to this other side to write it out properly. We move over to this side. So I'll be deleting the whole of this. So I'll be taking the log. Taking the log, we'll write it as the log of the likelihood function of the Laplace distribution will be equal to n. If you take the log of this, you get n negative n log 2. If you take the log of this, you have negative n log beta. If you also take the log of an exponential function, we get that same function, which is negative summation of xi minus mu all over beta. We take this as our equation star because we'll come back to it. So this is what we get. The next thing to do is to differentiate with respect to the mu. The mu, like we have already said, is our location parameter. So we say differentiate with respect to mu. To get the estimate of mu, we have to differentiate with respect to mu. So our partial derivative of the log of the likelihood function of the Laplace distribution is equal to, if we differentiate the whole of this, since there is no value for mu here, we get negative 0. If we differentiate the whole of this, the same thing, we get 0. There is no value, no parameter for mu. If we differentiate this, we get negative summation of xi minus mu all over beta to be what? Multiplied by negative 1. That means the value inside. So it then means that the log likelihood function of x mu beta is equal to this multiplied by this. You get summation of xi minus mu all over beta. So as I run from 1 to n, as I run from 1 to n, as I run from 1 to n. The next thing to do is to equate the whole of this to 0 to maximize mu. We equate the whole of this to 0. So we say equate to 0 to get to maximize this that is here. So maximizing it, we will move over to the next side as we are equating it to 0. So as we are equating this to zero, we have summation of xi minus mu all over beta is equal to zero, which also implies that summation of xi minus mu is equal to zero. So we have this. We then use that summation of xi minus mu is equal to zero. So this equation here, it is satisfied. This equation is satisfied when mu estimate is equal to the median of x1, x2 to xn. So this equation is satisfied when we know that this can be written as sine xi minus mu. So this equation is satisfied when mu estimate is equal to the median of the data that is given. So this is how we can get the estimate of mu. Now, the next thing to do is to also find the estimate of the parameter beta. For me to find the estimate of the parameter beta, what do we do? We recall from our equation star. This is our equation star. So we take the derivative of with respect to beta. So we say to obtain the estimate of beta, we say from equation star differentiate with respect to beta. If we differentiate with respect to beta, so we write it as the log of the likelihood function of the Laplace distribution all over beta to be equal to now. We differentiate the whole of this. If we differentiate the whole of this, since there is no value for beta here, we make this as zero, it turns to zero. It becomes negative zero. This, if there is a value for beta here, it becomes, if we differentiate the whole of this, it becomes negative n all over beta. If we differentiate the whole of this with respect to beta, we get negative, we already have negative sign, negative 1 all over beta squared summation of xi minus mu. So this is what we get. It then means that if we want to write this properly, we'll have our log likelihood function of x mu beta all over the beta is equal to negative n all over beta plus summation of xi minus mu all over beta squared. So this is what we get. The next thing to do is to equate the whole of this to zero. We also move over to the other side of the ball. So we equate the whole of this to zero to maximize beta. I will also do it here. So right equates to 0. We are equating the whole of this to 0. We will have negative n all over b plus summation of fi minus mu all over beta squared is equal to 0. Of course, this can move over to the other side to give us negative n all over beta to be equal to negative summation of xi minus mu all over beta squared. So this can cancel this. This will come over here to give us beta squared all over beta to be equal to summation of xi minus mu all over n. So this can cancel this. It then means that our beta estimate will be equal to summation of xi minus mu all over n. As I running from 1 to n, so this becomes our estimate for beta. While this here becomes our estimate for the mean, and this becomes our estimate for beta. Remember, this is our scale parameter, while the mean is the location parameter. So this is how to obtain the maximum likelihood estimation for the Laplace distribution. For more on this topic, you need to subscribe to this channel.